Ma'am?
Yes, sir. You can start now, sir.
Ma'am, Dhanlakshmi is a host.
Oh, okay, sorry, sir. Dhanlakshmi, could you please make Prasanna sir as host?
Yes, ma'am.
Yeah, dear.
Ma'am?
Yeah, sir. Yeah, sir. Tell me, sir. Yes, sir. You can start now, sir.
Ma'am, Dhanlakshmi is a host.
Okay, sorry.
I
Ma'am.
made this, sir.
Okay. Thank you, Dhanlakshmi.
Good evening, sir.
Yeah, good evening. You're from which college?
Sir, Rajaji Nagar Pre-University College, sir.
Rajajinagar.
Yes, sir.
RPA.
RPU, sir.
RPU.
It's nearby RPA only, sir.
Okay. Today we've had a chemistry question paper discussion for the new pattern. You are aware of the new pattern, all that, no? Sometimes later we will discuss about the new pattern, how the questions will be and what you have to study, all that I will tell you. All right, accordingly,
Okay,
learn it. Now we'll continue with the topic. Yesterday we were learning the chemical properties of aldehydes and ketones. Some of the questions on aldehydes and ketones we will learn, and later we will go for carboxylic acid topic. The product, I cannot teach you this because I didn't teach the chemical properties of aldehydes and ketones. No, chemical properties of aldehydes and ketones I have to teach you. Only then I can teach all this. And ketones we will learn, and then we'll go for the questions. Now this chemical reactions or chemical properties of aldehydes and ketones. Now aldehydes and ketones both are called as carbonyl compounds. Both are called as carbonyl compounds because both aldehyde and ketone contains C double bond O. Since both aldehyde and ketone contains C double bond O, they are called as carbonyl compounds. These carbonyl compounds give chemical reactions due to carbonyl group and alpha hydrogen. Now, reactions are because of two reasons. One is the carbonyl group, and the other one is alpha hydrogen. What is alpha hydrogen? Carbon atom bonded to the functional group. Carbon atom bonded to the functional group is called as alpha carbon atom. So carbon atom bonded to any functional group is called as alpha carbon atom. If this alpha carbon atoms contains hydrogen, they are called as alpha hydrogen. Now, carbonyl compound gives two chemical reactions due to carbonyl group as well as alpha hydrogen. Following can be classified into following categories. The first one, nucleophilic addition reaction, addition followed by elimination reaction, oxidation reaction, reduction reaction, reaction due to alpha hydrogen, condensation reaction, and miscellaneous reactions. So aldehydes and ketones, carbonyl compounds, can undergo so many reactions. Nucleophilic addition reaction, addition followed by elimination reaction. This addition followed by elimination reaction also can be called as condensation reactions, oxidation reactions, redox reactions. That is reduction reactions, not redox, reduction reactions, reactions due to alpha hydrogen, condensation reactions, and miscellaneous reaction. These are the reactions which aldehydes and ketones or the carbonyl compounds can undergo. And the first one is nucleophilic addition reaction. What is a nucleophile? What is a nucleophile? This nucleophile is electron-rich group. electron-rich groups are called as nucleophiles. Generally, negatively charged particles can be called as nucleophiles, like hydroxide ion, hydroxyl ion, OH minus, cyanide ion, CN minus. All right. And we have some neutral nucleophiles also. The example for a neutral nucleophile like calcium oxide, magnesium oxide, all these will be called as what? Neutral nucleophile. So electron-rich groups will be called as nucleophile. So nucleophilic addition reaction. This carbonyl compounds will undergo nucleophilic addition reactions. Now, since this carbonyl compound undergo nucleophilic addition reaction, a reaction with those reagents which on dissociation gives an electrophile as well as a nucleophile. So carbonyl compound gives nucleophilic addition reaction with those reagents which it dissociates to give electrophile as well as nucleophile. If nucleophile is weak, then addition reaction is carried out in the presence of a catalyst. So if nucleophile is weak, it is carried out in the presence of a catalyst. Product of addition reaction is as follows. Product of addition reaction is false. It's a general reaction. Now, what is this general reaction? R, C double bond O, R dash. Now, R here can be hydrogen, or it can be an alkyl group, or it can be an aryl group. Aryl group is benzene ring. Here, R can be hydrogen. If R is hydrogen, it will be called as formaldehyde. R can be CH3. CH3 means it is acetaldehyde. It can be an aldehyde or a ketone. Now, oxygen is highly electronegative. Since oxygen is highly electronegative, the bonded pair of electron will pull towards oxygen. So oxygen will gain negative charge and carbon will gain positive charge. Now, when this carbonyl compound is allowed to react with HNu. Now, this is, now for an example, Nu can be CN. So it will be hydrogen cyanide. Now, hydrogen will have positive character and cyanide will have negative character. So hydrogen here will have positive character, nucleophile will have negative character. So what happens? This is addition reaction, what we're talking about. So what happens? H attacks oxygen. Because H is positive, it attacks oxygen. Nu is negative and this carbon is positive. Therefore, opposite charges. This nucleophile attacks the carbon. So what's that we get? We get R, C. One pi bond will break down. So you get OH. Here you have C, a nucleophile. And you will get what? R. This is called as addition product. ADDUCT. This ADDUCT is called as addition product. I hope you understood the nucleophilic addition reaction. So any molecule which will dissociate to give a positive and negative ion will be, which it will give an electrophile. This H plus is an electrophile and Cn minus here is a nucleophile. So any molecule which dissociates to give an electrophile and nucleophile, only those molecules will get added on to carbonyl compounds to form an addition product. ADD stands for addition and UCT stands for product. In addition reactions, nucleophile adds on to carbonyl carbon. See, nucleophile adds on to carbonyl carbon and the electrophile adds on to carbonyl oxygen. See, this is electrophile. This electrophile gets added to carbonyl oxygen. Now, the relative reactivity of aldehydes and ketones. Aldehydes and ketones readily undergo nucleophilic addition reactions. However, ketones are less reactive than aldehydes. So aldehydes and ketones readily undergo nucleophilic addition reactions. However, ketones are less reactive than aldehyde. This is due to the electronic and steric effect. Now, for an example, okay, I'll just simply finish this, not to take much time, because this chapter is very detailed and the question asked is only 5 marks from this chapter. So not to spend more time. If you take an aldehyde like this, and if you take a ketone like this, acetone, now you can see this CH3 group. The CH3 group can be written as, the CH3 group can be written like this. Instead of writing CH3, I can write it like the CH, H, and H. Here also I write CH and H and H. Now what happens here? Now since these hydrogen atoms are there, the nucleophile or the electrophile to attack oxygen and nucleophile to attack carbon becomes difficult. Steric hindrance. This is called a steric hindrance. But in case of aldehydes, you can see the C double bond O is free. So easily what happens, the electrophile can attack oxygen and the nucleophile can attack carbon. This effect is called as what? Electronic effect and steric effect. Steric effect is availability of space. Therefore, aldehydes are more reactive compared to ketones. Now, these reasons we don't require inductive effect, all that. Inductive effect, again, if I have to tell, I'll finish it in one statement. This alkyl group is an electron donating group. So what happens? Electron pair will be moving towards carbon. All right, and electron will be moving away from oxygen. So electron becomes more richer here in carbon. All this detailed explanation is not required. You should remember aldehydes are more reactive than ketone. See here, formaldehyde is the simplest aldehyde. So formaldehyde is more reactive compared to acetaldehyde. Acetaldehyde is more reactive compared to ketone. This is because of electronic effect, and it's called as and because of steric effect. All right, follow to this.
Yes, sir.
Follow to this, yes. Now coming to some of the reactions, I have space here. I will write all the reaction and explain it here itself. Now we'll have to learn so many reactions. Now under that, the first one is nucleophilic addition reaction. Nucleophilic addition, correct? Nucleophilic addition reaction. Now, there are many nucleophilic addition reactions which you are supposed to learn. Under that, the first one will be addition of hydrogen cyanide. Addition of hydrogen cyanide. Now, this addition of hydrogen cyanide, mechanism of addition of hydrogen cyanide is an important question. This is an important question for 3 marks. So from aldehydes and ketones, if at all they're asking a mechanism, they can ask you addition of hydrogen cyanide. Now, how addition of hydrogen cyanide takes place? What's the mechanism? We're supposed to learn the mechanism of addition of hydrogen cyanide. Now, first, hydrogen cyanide is, we should know, it is HCN. This will dissociate in the presence of a base. This hydrogen cyanide will dissociate, HCN will dissociate in the presence of a base like OH minus to give cyanide ion and H2O. Cyanide ion and H2O. Now, this cyanide ion is a nucleophile. It's a nucleophile. Now, what happens if you take R, C, R dash, and O? It's a carbonyl compound. When we say it's a carbonyl compound, it can be aldehyde or it can be ketone. Aldehyde or ketone will be attacked by a nucleophile. When we say this is attacked by a nucleophile, here oxygen will have negative charge and carbon will have positive charge because oxygen is more electronegative. Therefore, cyanide will attack carbon. When cyanide attacks carbon, you get R, C, R dash, CN, and you get O minus. And you get O minus. Now, this O minus in the presence of water, the next product is water. So what happens? Water, we can write it as H plus and OH minus. This H plus attacks oxygen, O minus. So O minus gets eliminated in the form of a base. So the product, what we get is RC, R dash, OH, and CN. These kind of molecules, carbon having OH and CN groups, are called as cyanohydrin. It's called as cyanohydrin. This is the mechanism of a nucleophilic addition reaction. And in that first one, we are learning addition of hydrogen cyanide. Did you follow this? Followed?
Yes, sir. Yes, sir.
Now, we'll have to learn few questions here. That is, mechanism we are not going to learn. This is mechanism I've taught you. A few specific reactions. And the first one is addition of hydrogen cyanide with formaldehyde. Now, formaldehyde is HCH double bond O. HCH was formaldehyde. Now, when formaldehyde is allowed to react with hydrogen cyanide, so mechanism we are not learning. So you can write the mechanism also if you're wishing. So what happens? Now, instead of writing HCN, we will write CN minus. As per the mechanism, we will write CN minus. The CN minus will attack carbon. When it attacks carbon, we get HCH, O minus, and you get CN. Now, this will react with water. Now, water, we write it as H plus and OH minus. H plus attacks here, and this OH minus gets eliminated. So what we get? HCH, CN, and cyanohydrin. It's called as formaldehyde cyanohydrin. So addition of cyanohydrins will give you formaldehyde cyanohydrin. Addition of hydrogen cyanide to formaldehyde gives formaldehyde cyanohydrin. Now, similar reaction, if I take, did you follow this reaction?
Yes, sir.
Now, if you take with acetone, now what's the formula of acetone? It will be CH3. Here also it is CH3. CH3, CO, CH3 is acetone. So what you will get? You will get CH3 here. Here you will have CH3. And here it's CH3. Here also it is CH3. This will be called as what? Acetone cyanohydrin. Since the parent molecule is acetone, the name of the product formed will be called as acetone cyanohydrin. Did you follow? Yes.
Yes,
I
sir.
think addition of hydrogen cyanide, you have understood. I've given two examples. The general mechanism we have learned, one with formaldehyde, the other one with acetone. Now we will learn, again, it's a nucleophilic addition reaction only. The first set of reactions, what we learned was from hydrogen cyanide. Now we learn with the next compound, that is addition of nucleophilic addition reaction of aldehydes and ketones with sodium bisulfite. Now this is with sodium bisulfite, or we can write under that addition of sodium bisulfite. Now, aldehydes and ketones in general, we can represent a carbonyl compound like this, R dash double bond CO. When this is allowed to react with sodium bisulfite, NaHSO3. Sodium bisulfite is NaHSO3. What happens is this hydrogen attacks oxygen. SO3 and Na will attack carbon. So what's the product you get? The product you get is R, Cr dash, you get OH, and you get SO3Na. SO3Na. This is called as an addition product. It will be called as sodium bisulfite adduct. Sodium bisulfite, PHIT, addition product. Therefore, it is called as sodium bisulfite adduct. So you understood how sodium bisulfite reacts with a carbonyl compound. Now we will try to take a specific example and we will learn. And also we are supposed to learn an important question here. I will tell you what is that important question in few minutes time. Now, when this is allowed to react, now with formaldehyde, we can write addition of sodium bisulfite with formaldehyde. Formaldehyde is HCH double bond O. When this is allowed to react with SO3Na attacks carbon, therefore you get HCH, OH, and SO3Na. This will be called as formaldehyde sodium bisulfite. Formaldehyde, sodium bisulfite. Now, similarly, if you take acetaldehyde, this is CH3, not acetaldehyde, oh, sorry, this is acetone. This is acetone. And this acetone, when you heat or allow it to react with sodium bisulfite, H attacks oxygen, SO3, Na attacks carbon. So you get CH3, CH3, single bond OH, and you get SO3, Na. This will be called as acetone sodium bisulfite. Acetone sodium bisulfite. Now, the important question, what you're supposed to know is this. The same reaction, the third one, it is with acetophenone. Addition of sodium bisulfite to acetophenone. Acetophenone is C6H5, CH3 double bond O. This is the formula of acetophenone. This acetophenone, when you allow it to react with sodium bisulfite, you get no product. No product. Because already we learned in the class, aldehydes will react with, will undergo nucleophilic addition reaction easily compared to ketones. See, this is a ketone. C6H5 is a bulky group. CH3 is also a bulky group. Therefore, due to electronic and steric effect, the sodium bisulfite will not be in a position to react with the carbonyl group. Therefore, no product will be formed. So due to steric hindrance, due to electronic and inductive effect, electronic and what? Steric effect. Steric hindrance, not steric hindrance. So you'll write steric hindrance. This reaction will not take place. It's an important question you should remember. So ketones with bulky group, such as acetophenone or maybe diisopropyl ketone or any bigger ketones, any bulky ketones will not react with sodium bisulfite because of the electronic and also steric hindrance. Followed?
Yes, sir.
Yeah. The next one is addition of Grignard reagent. Addition of Grignard reagent. Now, what is this addition of Grignard reagent? We will learn. Now, you know what is Grignard reagent? Grignard reagent is RMGX, represented as RMGX. Addition of Grignard reagent. Now, addition of Grignard reagent to aldehydes and ketones, followed by hydrolysis. Here, two steps will be there. One is addition of Grignard reagent, followed. Second one is hydrolysis. Now, I will just give you a general example. Followed on the general example, we will have to learn three reactions. The general reaction for a carbonyl compound is RCR- and double bond O. This is the representation of a carbonyl compound. We know that in carbonyl compound, oxygen will have negative charge and carbon will have positive charge. And here, Grignard reagent is represented as RMgH. Now, this magnesium is electropositive. Magnesium is a metal. When magnesium is a metal, it will donate electron. When it donates electron, it gains positive charge. And R is electronegative. It accepts electron. Therefore, R gains negative charge. So what happens now? R attacks carbon, Mg and X attacks oxygen. So we get an intermediate product, RCR- OMgX, and you have what? R. Did you follow this step?
Yes, sir.
Yeah. Now, this when you hydrolyze, hydrolysis generally takes place in the presence of an acid. So H plus. So what happens? This water, we can write it as H plus and OH minus. So magnesium will have positive character and oxygen will have negative character. Now what will happen? To this oxygen, what gets bonded? Hydrogen gets bonded. And to magnesium, what gets bonded? OH. Therefore, what you get? Mg, OH, and X. Magnesium hydroxy halide. It's a byproduct. Now, what's the product you get? You get R, C, R dash. You have this R, and you have what? OH. So the product what you get is called as alcohol. The product what we get is alcohol. So whenever Grignard reagent is allowed to react with a carbonyl compound and followed by hydrolysis, the product what we get is alcohol. Now, first, second, and third. I have to finish all these three. I will rush through. I hope that you understood this mechanism. If you understood this mechanism, the first one is with formaldehyde. The formula of formaldehyde is HCHO. This is formaldehyde. Now, when formaldehyde is allowed to react with a Grignard reagent like CH3, MgBr, methyl magnesium bromide. Now, when it what happens now? Magnesium is positive, carbon is negative, oxygen is negative, carbon is positive. What happens? Now, this carbon attacks this carbon, and magnesium attacks oxygen. So what do we get? We get an intermediate product, HCH. You have what? CH3 here, and you have OMgBr. Now, this again, when you hydrolyze, hydrolysis in the presence of an acid. So what happens? Now, H plus will attack what? Oxygen, and OH minus will attack what? Magnesium. So what's the product you get? You get CH3. I can write CH3, CH2, and I can write what? OH. Plus, what will I get? Mg, OH, and Br. Now, this is ethanol. This ethanol is what alcohol? It's a primary alcohol. So when formaldehyde is allowed to react with Grignard alcohol, primary alcohol. In specific, it is primary alcohol. Now, the second one, we will take acetaldehyde, CH3, CH double bond O. Now, this acetaldehyde, when allowed to react with methyl magnesium bromide, this is acetaldehyde. When it's allowed to react with methyl magnesium bromide, what happens? Oxygen gains negative charge, carbon gains positive charge, magnesium is positive, carbon is negative. So you know what happens. Now this CH3 attacks this carbon, and this magnesium attacks this oxygen. So what's the product you get? You get CH3, you have CH, you have CH3, and you have OMgBr. Now this when you hydrolyze, what happens? H attacks oxygen, OH attacks magnesium. So therefore we'll get what? I can write CH3, CH, CH3, and OH. Now what alcohol is this? What alcohol is this? It is 2-propanol. 1, 2, 3. 2-propanol. This 2-propanol will be an example for what alcohol? Secondary alcohol. Did you follow?
Yes, sir.
Yeah. Now the third reaction is we will take a ketone, that is acetone. We will take acetone like the CH3, COO. These three reactions are there in your syllabus. They can ask you any specific reaction. Since this is a lengthy chapter, you need to learn all the reaction. I don't know why they made this chapter so important compared to all the other chapters. Now, again, the same reaction here. CH3 attacks this carbon, magnesium attacks this oxygen. So you get CH3, CH3. Here also you have CH3 and you have OMgBr. This on hydrolysis. So H plus will attack oxygen, OH minus will attack magnesium. So you get CH3, CCH3, CH3, OH plus MgOH-Br. This is called as tertiary alcohol. It's called as tertiary butyl alcohol. So you should clearly observe. So reaction with Grignard reagent. Carbonyl compounds like formaldehyde gives primary alcohol, acetaldehyde gives secondary alcohol, and ketone and acetone gives tertiary alcohol. So these are the reactions with Grignard reagent. All right. So we will learn the next set of reactions now. Now I have to erase all this. So give me some time. Any clarification with these 3-4 questions, what you've learned?
No, sir.
No? Okay.
No, sir.
Yeah, okay. Just give me some time. The next set of reactions is condensation reactions. Now, what is this condensation reaction? Condensation reaction. Now, a carbonyl compound, generally we represent it as R, C double bond O, R dash. We can represent it like this also. R, C double bond O, R dash. Now, when this is allowed to react with a derivative of ammonia, like ammonia, we know that it is NH3. The formula of ammonia is NH3, like this. If hydrogen is replaced by some other group, one of the hydrogen is replaced by some other group, then we call it as derivatives of ammonia. Now, this derivative of ammonia, we represent it as NH2N and Z. So one of the hydrogen is replaced by what group? Z group. Now, what happens? Now, this hydrogen and this oxygen gets eliminated as water. When they get eliminated as water, what's the product we get? You get R, C double bond, En, Z, and you have R dash. So this Z can be what? Here, Z can be OH, or it can be NH2, or it can be CONH2, etc. So Z can be anything. So this kind of reaction, condensation reaction, is a reaction in which we get a product and also a byproduct. In addition reaction, there was no byproduct. In the previous reaction, we have learned hydrogen cyanide, sodium bisulfite, all that. In those kind of reactions, there was no byproducts. But in case of condensation reaction, there will be byproducts. There will be byproducts, like water. Now, we'll have to learn specific reactions. We'll learn specific reactions. The first reaction is reaction with hydroxylamine. Reaction with hydroxylamine. Reaction with hydroxylamine. Now, what is this hydroxylamine? We know ammonia is NH3. So if one of the hydrogen atom of ammonia is replaced by OH group, then it's called as hydroxylamine. So one of the hydrogen atom of ammonia is replaced by OH group, then it is called as hydroxylamine. Now, if we take this is the general reaction which I've given. We will take specific example here, like formaldehyde, acetone, aldehydes. anything. We'll take acetaldehyde. The first reaction, we will take acetaldehyde. This acetaldehyde, when allowed to react with hydroxylamine, NH2OH, this is hydroxylamine. What gets eliminated? This H2 and O gets eliminated as H2O. In place of O, what goes? NOH. So what's that you get? You get CH3, CH, double bond, NOH. This kind of molecules, NOH groups, are called as oximes. So the specific name for this molecule will be acetaldehyde oxime. It will be called as acetaldehyde oxime. Now, similarly, if you take the second reaction, second example, if you take acetone, and this acetone, when it is allowed to react with hydroxylamine, so what happens? OH and H2 gets eliminated as H2O. Now, what is that we get? You have CH3, CH3, double bond N and OH. This is called as acetone oxime. It's called as acetone oxime. So NOH group is called as oximes. So condensation reaction, the first condensation reaction is reaction with hydroxylamine. So whenever aldehydes and ketones or carbonyl compounds are reacted with hydroxylamines, the respective oximes are formed, OXIME. The respective oximes are formed. Followed?
Yes, sir.
The next is hydrazine, reaction with hydrazine. I will write it here only. I'll modify it here only. Now, in case of hydrazine, if one of the hydrogen atom of ammonia is replaced by another NH2 group. See, ammonia is NH3. One hydrogen is replaced by NH2 group. So NH2 is called as hydrazine. N2H4 is called as hydrazine. So hydrazine we can write like this. Hydrazine we can write like this. So what happens? What's the product you get? We will see the product what we will get. Now, what happens? Now this is NH2 and this is NH2. Water gets eliminated. So what happens? You have N single bond NH2 plus. Now what will be this called as? This is called as hydrazone. N NH2 group is called as hydrazone. Therefore, the name of the molecule will be acetaldehyde hydrazone. The molecule will be acetaldehyde hydrazone. Here, if you react it with acetone, this is acetone. So the product you get is N NH2 here. Water gets eliminated in NH2 and plus. This is called as acetone hydrazone, ZONE. When you use hydrazine, the product is named as hydrazone, ZONE. So here it will be acetaldehyde hydrazone, and here it will be what? Acetone hydrazone. Followed?
Yes, sir.
Yeah. The next question, not next question, the next concept. The next concept or next is reaction with phenylhydrazine. Phenylhydrazine. Now, what is this phenylhydrazine? Phenylhydrazine. Now, this phenylhydrazine will have a formula. Hydrazine formula is what? NH2, NH2. If one of the hydrogen is replaced of hydrazine by phenyl group, C6H5. See, NH2, NH2 is hydrazine. One of the hydrogen is replaced by C6H5. It's called as phenylhydrazine. So what will happen now? I will rewrite the structure. I will rewrite because you need space. So I will rewrite. Acetone, I will not write. You know this, so many reactions I've made. This is phenylhydrazine. So when you heat it or when you allow it to react, what happens? Water gets eliminated. When water gets eliminated, what we have? What you have? What's the product you get? CH3, CH, double bond, N, single bond, NH, and what you have? C6H5. This is called as acetaldehyde phenyl hydrazone. Are you following the names? What I'm telling? How to name these molecules? Phenyl hydrazone. Followed? Similarly, similarly with acetone. Will you write the reaction with acetone? Acetone will react with phenyl hydrazine to give acetone phenyl hydrazone. In place of this hydrogen, what you will have? C6H5. In place of this hydrogen, what you will have? C6H5. That will be called as what? Acetone phenyl hydrazone. Okay, now did you follow? Yeah.
Yes, sir.
Yeah. The next one is reaction with 2,4 dinitrophenyl hydrazine. 2,4 dinitrophenyl hydrazine. This 2,4 dinitrophenyl hydrazine is called as Brady's reagent. It's called as Brady's reagent. So what is this Brady's reagent? DNPH. I don't know whether you have been using DNPH. Organic reactions you are not doing in your labs. That's okay. So this DNPH is called as dinitrophenyl hydrazine. Its dinitrophenyl hydrazine is abbreviated as DNPH. All right. Now, what's the formula of phenyl hydrazine? Firstly, 2,4-diphenyl hydrazine. How do we mark this 2,4-diphenyl hydrazine? Now, the general reaction I'll tell you, specific example you will know. So, ketone, a carbonyl compound can be represented like this. R-C double bond O. It can be aldehyde, it can be a ketone, anything. Now, phenyl hydrazine, what's the formula? NH2, NH, C6H5. C6H5, can I write like this? A benzene ring. Can I write a benzene ring like this? C6H5. Now, if I write this as a functional group, this is first carbon atom, this will be second. Here I have 1 NO2, this is 3, and this is 4. So this is called as 2,4 dinitrophenyl hydrazine. Now, when you allow this to react with aldehyde or ketone, what happens? H and OH gets eliminated as water. So what is left out? You have R, C, R dash, double bond. You have N, single bond, NH, a benzene ring. You have NO2 here, and you have NO2 here, NO2. So this will be called as 2,4 dinitrophenyl hydrazone. This is an orange solid. It's an orange colored solid. It's an orange colored solid. Followed this. The last
Yes, sir.
condensation reaction I have to teach you. So many condensation reactions we learned. What are that? We have learned with hydroxylamine. We have learned with phenyl hydrazine. We have learned with hydrazine. We have learned with Brady's reagent. That is 2,4 dinitrophenyl hydrazine. The last reaction, what I have to teach you with respect to condensation reaction, I will write here. That is with semicarbazide. Semicarbazide. C-A-R-B-A-Z-I-D-E. Semicarbazide. Now, a ketone or an aldehyde, we represent it like this. Now, what is the semicarbazide? We know hydrazine is NH2, NH2. If one of the hydrogen is replaced by C double bond O NH2, amide group. This is called as amide group. One of the hydrogen is replaced by C double bond O NH2. So what happens? This H2 and O gets eliminated as water. So what else we have? We have R, C, R dash, double bond N, single bond NH, single bond C, double bond O, and NH2. So these are called as semi-carbazones. Semi carbazone. Semi-carbazides gives you semi-carbazone. If you use formaldehyde, it will be formaldehyde semi-carbazone. If you use acetaldehyde, it will be called as acetaldehyde semi-carbazone. If you use acetone, it will be called as acetaldehyde semi-carbazone. Are you following? These are the condensation reactions which you should know. It is a lengthy chapter, lot of reactions. I hope that you have been able to understand the reactions. So we'll continue a few more named reaction, and let's see how much more we can do today. The next one is reduction reaction. So what we have learned is nucleophilic reaction. Now the next one, what we have is reduction reactions. We learned that aldehydes and ketones also will undergo a reduction. Reduction of alcohols. Reduction of alcohols. So aldehydes and ketones. Aldehydes and ketones are reduced to primary and secondary alcohols respectively. Primary and secondary alcohols respectively. Reduction is addition of hydrogen or removal of oxygen. That's called as reduction. Now for an example, if you take acetaldehyde, this acetaldehyde is represented like this. This acetaldehyde, when you allow it to react with a strong reducing agent like sodium boron hydride or lithium aluminum hydride, these all are very strong reducing agents. They will give nascent hydrogen. Hydrogen in atomic state is called as nascent hydrogen. So 1 mole of an aldehyde or a ketone requires 2 moles of hydrogen. One hydrogen attacks oxygen, the other hydrogen attacks carbon. So we get CH3, CH, here H, and OH. This is ethanol. This ethanol is a primary alcohol. Now, similarly, if we perform the reaction with a ketone, acetone, if you take, this is acetone. Now, this when you reduce using lithium aluminum hydride, one oxygen attacks this hydrogen, the other hydrogen attacks this carbon. So you get CH3, CCH3, here H, and this is OH. This is 2-propanol. This 2-propanol is a secondary alcohol. So aldehydes on reduction gives primary alcohol, and ketones on reduction gives secondary alcohol. So other chemical reactions we will learn in the next class. Madam?
Yes, sir.
I'll stop now.